This is a live class. You guys got this page? We discussed different types of slope options yesterday. We didn't talk about them very thoroughly, but we talked about some different options that you could have. Options for slope. Well, the most popular example I keep giving you guys are pictures that go up, right? X, there's Y. What kind of slope is this? Positive, negative, no slope, undefined slope? What do we think? What would you expect to find? Positive slope. It's going uphill. Because once again, when you look at a graph, how do you read it? Left to right, like a book. So as you look at it left to right, it's going up. See, you start here and you go up, left to right. Okay? Now you can change the steepness of that. Who cares? Let's see. I'm going to have one that does this. What kind of slope do I see here? Negative slope. Oh, so if I did the math between 2 points on the slope, would I expect to have a negative somewhere? Yeah. It has to tell me to go down or left or wherever I stick that negative. Another one. How about this? A flat line. No slope. Oh, quantify no. No slope. What's the slope equal to? Give me a number for no. 0, okay. Slope equals 0. Oh, and then we talked about the really bad one. We said sometimes it's possible to get something like this. Straight up and down. And last time we discussed why this was not a function. What test does it fail when we just even visualize this thing? It fails the vertical line test. So it only makes sense that the slope is going to be unhappy, right? Sure, it's a line, but what kind of slope do we have here? Yes, slope is undefined. Why would we ever make a slope undefined? What makes numbers break? It's the number one thing we've focused on in here. When we're talking about domain, we're talking about numbers being, well, they cross each other repeatedly. But as far as fractions go, because the slope is a fraction, right? Mathematically, when you found that fraction, what would you probably be finding that would make this thing undefined? What would be happening in the bottom of that fraction? What number? 0. Okay. When you have a straight up and down line, you get a 0 for your side-to-side movement. Oh, check it out. Look. It's true. From one point to the next, this thing doesn't go side to side, does it? It's always going straight up and down. So the ideas kind of connect together pretty well. Very cool. Let's practice finding slope a few more times. And we may even graph some lines, just for kicks. Let's see. I'm going to give you 2 points. I'm going to say given. How about a line that goes through these 2 points? A line going through. You guys help me. What points do I want this line to go through? I'm just making this up, so help me out. Don't pick big numbers because we don't want big numbers. 0, 1. Okay, what's another point it's going to go through? 1, 2, 4. So given that we have some line that goes through these 2 points, we're not even going to talk about the equation yet. We're just going to say we know it goes through these 2 points. I want you to find the slope. Which point do you want to be the first one? Point 1, x 0, 1, or 2, 4? Okay, so I'll notate this with sub 1s, x1 sub y1, right? To remind myself I'm using it as the first point. For the second point, I'll put x2, comma, y2. You don't have to write that. I'm just writing it to help remind us which one we decided to use when. Slope is equal to, in words, it's rise over what? Good, rise over run. Also known as the change in y, in the up and down, over the change in x. y2 minus y1 over x2 minus x1. That's the formula. But again, that's my thought process and how I personally remember it. I actually go through all 3 of those steps every time I write that formula from memory, because I like to take the applied part. It's always mine, because it's always that change in between. Yeah, and both these right here would be considered formulas for the slope. One's an applied approach on how you look at it, and the other one's, you know, the formula kind of thing. So let's see. y2, which one's y2? 4 minus y1, okay, over x2, 2 minus 0, what do we get? 0, 2. Somebody describe this movement. What's happening? This is the up down part, right? So it's going 3, what, up or down? Oh, that's a positive 3. Okay. And on the bottom, that's the run, that's the side-to-side stuff, so it's going 2 to the right or left? To the right. And it does depend a lot on how you like to see numbers. Because notice, I'm looking at these 2 being positive. If I had a negative in front of that fraction, would it matter if I put it on top or bottom? No, of course not. Would it matter if I just wrote it twice just because I like writing negatives everywhere? Negative on top of a negative? What happens to negative divided by negative? Oh, so if you have a negative coming out of this thing, sure you can put it on top if it makes you happy. Sure you can put it on bottom, but don't start just putting them everywhere. Because if you do that, you change the whole value of it. You can't have negative in both places. If you do, it's positive. It cancels. So be really careful with that, okay? You'll come across some graphers who prefer it on top or bottom. Personally, I always stick them on top. Some people like to put it on bottom and think about walking to the left. It depends on the person. Just don't start writing the negatives everywhere. That changes everything. In fact, let's look at one where you might have that. How about, let's give you 2 new points. Let's say that you have, same problem, given a line going through. This time we'll say it's going from 1, 3 Okay. I'll say I have now this line that goes from 1, 3 to negative 1, 4. Find the slope. I'll call the first one x1, y1. That's what I always do. Second one is x2, y2. Okay, so we say 4 minus what? 3. Negative 1 minus 1. So I get a 1 on top and what on the bottom? Negative 2. Okay. You can leave it that way, or you can write it as negative 1 over 2. You do not write that negative on those, but notice how it's the same thing since there's just one negative. It really depends on what makes you comfortable. Again, I put it on top because I just like putting it there. It doesn't really matter how you look at it, though. With it on top, the top talks about up or down. Would that negative mean down or up? Down. Down 1. The bottom, it's positive, right? So it's going which direction? Right or left? Down 1, right 2. Over here, if you had used the first one, the 1 on top would have meant up 1, left 2, wouldn't it? See, I just don't like thinking about left. I know it's funny. I like to always go up or down and always go to the right. That's why I put my negatives on top. But if you left it over here, it'd be the same thing. It adjusts itself, doesn't it? Let me show you. 1, 3, let's see. 1 for the x, 1, 2, 3. So I'm sitting at this point, okay? Let's see, if I had used the second one, my favorite one, you would have go down 1, right 2 as your driving direction or your walking direction. So I'm going to go down 1, right 2. Okay? If I use the other one, which would have been up and to the left, I would have gone from any point on the line, so I can use this one or this one. Let's say I use this one, though. I'll go back to the original. I would have gone up 1, and to the left, how much? 1, 2. Oh. So either way, I still get a point on this line. You see that, guys? It didn't matter. Let me change colors for a second. I hope people can still see it. But it doesn't matter if I went up 1, left 2, or if I went down 1 to the right 2. Both ways gets me something else on that line. And that's all I care about, isn't it? I only care that I get a second point on the line. Kel.
Okay, when you first got on 1 down.
Uh-huh.
Why don't you start way up there and you got 2 lines on your graph there.
Repeat the question.
I'm looking at just going 1, 2, 3, and you started up there around 3.
Oh, why did I start right here? I just picked one of the points. Whenever you're graphing, I really could have put both points and just drawn a line, but I started with this point, 1, 3, because I knew that the line went through both of these. So I said I'll just start there and use my stepping technique to illustrate to the class. Now, of course, this is also on the line, -1, 4. So if I went to -1, 1, 2, 3, 4, that's also on there. It just depended on where I wanted to start. And now it doesn't even matter. Now I can start anywhere and use that walking technique to get to the next point. I mean, I could start at this point and go down 1 to the right 2, down 1 to the right 2. I'd fall right back on the line forever. Down 1 to the right 2. Wait. Down 1 to the right 2. Let's just show you the steps there. Keeps happening forever. Same thing. Very cool. Numbers can be as big or small as they want. The process is still the same. So at this point, you've seen a negative slope where you read left to right and you see a line going down. And of course, the first example, you saw a positive slope, right, where it was going up. We talked a little bit about what would happen with an undefined slope. We said that in your fraction, you would end up with a 0 on the bottom, right? So undefined slope has a 0 coming out on the bottom. And a slope that equals 0, well, probably there's a 0 on top. 0 divided by something. So if you subtract your 2 points, you'll start to get values that tell you what the picture is going to look like before you even graph it. Let's make sure, well, are you guys feeling comfortable with starting from one point and using that road map to get to the next point? Let's